Okay, so we've actually already done part of this. We've actually learned how to multiply radicals, but it's been a while since we've done it, so I just want to review it real quickly. Then we're going to talk about dividing radicals, which is very similar to multiplying. It's just dividing, right? You just have to use the same rules with multiplying that you do with dividing. And then the third is rationalizing the radicals. Okay, so and that's a special thing. Rationalizing, there's a rule in algebra that says never leave a final answer with a square root sign in the denominator. Never, ever, ever. Okay, and to be totally honest with you, it came from that rule came from calculator era. It came from my era when nobody had calculators in school. My dad got a calculator when he turned 40, I think. We bought him a calculator. It was the first personal calculator available. It was this big, and it was $300, and it added, subtracted, multiplied, and divided, and that's it. Did nothing else, right? The little $2.50 ones at Walmart do more than the $300 one that we bought him. It's amazing. But anyways, I'll explain all that as we get to it. First of all, multiplying. When I say the square root of 2 times the square root of 6, when you're adding, you cannot add those two together, right? If you're adding or subtracting, there's no way I could add these two together because they're not like terms. I can't go 2 plus 6 is 8. So square root of 8, I can't do that. I'd have to see, okay, square root of 2, I can't simplify that. Square root of 6, I can't simplify that. I'd have to leave it like that. But when I'm multiplying, it's okay to multiply them together. And so what you're going to do is you're just going to put them all underneath the same radical sign. And what is 2 times 6?
12.
12. So you just do square root of 12. Now, the only problem is that sometimes, if you can't do much here, once you've multiplied them out, you realize, oh, I can simplify that. How do I simplify that?
I'll divide it by 2.
2 and 4.
No,
wait,
it would
no,
be
3 and 4.
3 and 4.
And
So
two.
that's the same as saying the square root of 4 times 3, right? Yes?
Yep.
And what's the square root of 4?
2.
So I can take the 4 out, put the 2 outside. So my final answer is 2 outside, and then times the square root of 3. That's easy, right?
Yeah.
I just multiply them together, put them under the same square root sign. Then I see if I can simplify that. Right? Does that make sense? Okay. Let's say I gave you, what if I gave you the square root of 5 times the square root of 7?
Equal 35.
The square root of 35. Now, let's see, is there any way I can get that, simplify that? 5 times 7 is the only thing that makes 35, right? And neither 5 nor 7 is this perfect square. Therefore, I can't go any further. That's as far as I can go. What if I gave you this? Square root of 6 times the square root of 6.
36.
All right, so it's the square root of 36. Can I go?
Equals 6.
Which equals 6. Oh, that's interesting. All right, how about this? The square root of 8 times the square root of 8.
It's 8.
It's
Equals 8. That's
right. Look at that. It's the square root of 64, right?
64.
Which is 8, right? Well, that's interesting. So whenever I'm multiplying the exact same term, right? Basically square root of whatever times the square root of the same number, it's just that same number, right? That's the definition of what a square root is, right? Okay, so then what if I gave you this? The square root of x plus 4 times the square root of x plus 4.
X plus 4.
It's just x plus 4.
It's
Beautiful.
like 1.
Okay. What if I gave you something like this? The square root of 2 squared.
Would it just be the
The square root of 2. 4. 4. No, wait. Yeah. 4.
Be the square root
No,
of
but then
two.
the square root of, then the square root of 4.
So remember what that means. Square root of 2 squared is
Square root
equal
of
to
2.
the square root of 2 times the square root of 2.
But that equals square root.
And that equals what?
4.
2.
2. Square root of 4, which is 2. Yes?
Yeah.
Yes?
So it's square root.
So it's just 2. Right? Does that make sense? So square root of x minus 7 squared.
X.
Square root of x minus 7.
No, it's just x minus 7.
It means the square root of x minus 7 times the square root of x minus 7, which is x minus 7. So whenever you multiply the exact same things together, you get just that thing outside of the square root, right? What if I gave you this, though? What if I gave you 3 square root of 3 squared? Just remember what that means. That means 3 square root of 3 times 3 square root of 3. I'm going to write that out because I just want to be sure I don't forget that. 3 square root of 3 times 3 square root of 3. Yes? And I can move things around, right? When I'm multiplying, right? I can move things around. Like it's commutative property. I could put this 3 and this 3 together. So that's the same as saying 3 times 3 times the square root of 3 times the square root of 3. You guys see that? Oliver, you see this?
Yeah.
Does that make sense?
Wait, so
Luca, you
3
see
is
this?
square root of 3.
So you can't see this, right?
Oh, I can't.
So
I need to
3 square root of 3,
9 square root of 3.
3 square root of 3 square root of 3 squared, right? Which means 3 square root of 3 times 3 square root of 3. But I'm putting the two 3's next to each other now. And I'm putting the square root of 3 times the square root of 3 next to each other. What's 3 times 3?
9.
9.
9
So it's the 9 square root of 3.
times, what's the square root of 3 times the square root of 3?
9.
9, but it's square root of 3, so.
So it's 9 square. Wait, 9 square root of 3.
Wait,
Nine
what's
square root
the
of
square root of 3 times the square root of 3?
Square root of 9.
9 square root
Which
of 9.
is,
Which is square root of
3.
Or,
That's-
oh, which is just 3.
Which is just 3.
9
So
square root of-
square root of 3 times the square root of 3 is 3.
27.
So the final answer is 27. Yes? You see that?
Oh my god.
I'm totally running out of time. Totally. Okay. Can I erase?
Not the right side. Like,
What? Not the right side.
Yeah.
Okay. So now dividing is the same thing. And I'm going to only have you have to do through 16. We'll deal with rationalizing tomorrow. But dividing is the same thing. If I gave you the square root of 16 25ths, okay? It's all under the same radical sign. So, Una, you should be taking notes. You'll never be able to do your homework without taking notes. Square root of 16 over the square root of 25. That's just to separate it as the square root of 16 over the square root of 25. Similar to the multiplying. That when you have the square root of 16 times the square root of something, you can also just put them all under the same square root sign. And then the reverse is true. If they're all under the same square root sign, you can separate them. Right? Yes.
Are we gonna have these on our homework?
Yes.
Yeah.
But these are easy because look, what is the square root of 16? This is a perfect square.
4.
Right. So immediately I simplified the numerator. What about the denominator?
4.
Yeah. Square root of 25 is 5. So your answer is 4/5. Right? Easy? Piece of cake?
Yeah.
Right? How about this one? Square root of 36 over 81.
6 9s.
6 ninths, exactly. All right. Square root of 4 over 49. Square root of 4 over
2 7.
2 sevenths, right? 2 sevenths, exactly. Right? Everybody with me? Makes sense? Now what if I gave you one that didn't have a perfect square in it? Like what if I gave you the square root of 2/50ths?
1/25.
Oh my God! Who said that? Who said that? Who said that? Who said that?
Oliver.
Oliver, that's amazing. Oh my God. All right. Wait, so sometimes, like 2 is not a perfect square, 50 is not a perfect square. So, but I noticed they're both even, just like Oliver did, right? And I'm gonna rewrite it now as 1/25.
Why?
Because that's like.
They're perfect squares. Look, now we have perfect squares.
Wow.
The square root of 1 is, right? Square root of 1 is 1. Square root of 25 is 5. Right?
Oh,
You see what I mean? All right, let's try another one. Square root of 272s.
it'd be what?
Square root over, and then it would be
Square root of what?
1 over
2, 5, 6.
Whoa.
Which is, what's the final answer?
1 over 6.
1/6, right? Awesome. Okay, and I think that's all I'm going to have you do.
Wait, please don't erase these.
Okay, one of those is on the homework. Just so you know.
Oh no.
You guys are lucky.
What we'll do.
And I think that's as far as I'm going to go. So you only have to go through number 16 on the homework.
I only have to do
When
number
it-
16.
When it,
That's how. I like this.
Can we start on it now? Because I'm very
Easy. I'm
busy
be done
tonight.
like.
the
30
sim
seconds.
okay, when it talks about rationalizing the denominator, don't worry about that part. There's 4 problems that say guys. There's 4 problems on the back that say rationalize the denominator.
Okay.
Don't do those. But you can do all the others, including the last 2. You can do the last 2 as well, which are just adding, right? So that's it. So that's my very quick, unbelievably brief